Okay, so now you know precision at k, but this is only an intermediate step to the one that we are really interested in, which is called the average precision at n. And that's the typical scenario that you recommend n items to a user. Yeah, let's say you show him the next 5 books to buy or the next 10 movies to watch. Then this n is the number of recommendations you give to a user. And now you want to know what is the average precision for this number n. So this is called AP at n. So here, to be able to calculate it, you also need to know how much there could be recommended. So for now, let's say this is a value between 1 and n. Otherwise, it's kind of a special case. So ideally, it could be that there are, out of the 10 items, all 10 are relevant. But it could also be that you have to do 10 recommendations, but for this user, only 5 were actually possible. Then there are a few that were not actually relevant. So to compute the average precision at n, you basically do another weighted sum. You compute the precision at k, multiply it with whether the item k was relevant, and you do this from 1 to n. So you do it over all the n recommendations, for example, from 1 to 10. So there is another exercise for this. It's the same table on the worksheet, just the last column. And if you look at the result, you'll see that the average precision basically will give you a higher score if a correct recommendation is higher in the rank. And that's intuitive what you want. If, let's say, you make 10 recommendations, 5 are correct, then it's better that the 5 correct ones appear in the top 5 and not in the bottom 5. And this is what this AP at n is calculating. So it rewards, it gives a higher score to good recommendation that appear higher up in the list of recommendations. So good luck with calculating AP at n, and I'll see you back soon.